Hello students, this is Ms. Dalton and this video is on polynomial characteristics. In this unit, it's going to be very important that you can identify different intervals of the graph doing different things. And so on this first screen, we're going to identify the given interval on the graph provided, and we're going to use different colors for each interval. So in this first graph, we have the interval from negative infinity to 0. And that's talking about your domain. All of these intervals are on your domain, which is your x values. So if I highlight that part in red, that's going from negative infinity up to 0. So here is 0, and we're going to stop at that point. So this is going to have a solid point based on the fact that this is a bracket, and it's everything before that, so it's going to be all of this. Then when I change colors, so now I'm going to graph the part of the interval that's from 2 to 4. So here's 2, and this is going to be an open circle since we have a parenthesis. And we're going to go all the way to 4, and so 4 is here, but on the graph it would be right here, and that's going to be an open circle as well. So let me get my pen so that you can see that a little bit better. This is going to be an open circle, and this is going to be an open circle right there, but everything's going to be shaded in between those 2 points. So now let's look at the second graph. So this has us going from -1 to +4. At -1, that's right here, and I'm going to follow my graph all the way over until it stops at 4. So it looks like 4 stops right there. And then you want to make sure that you put whether it has an open circle or a closed circle. Both of these are brackets. So that means that here we have a closed point and here we have a closed point as well. Let's look at the next interval. So the next interval is from 4 to infinity. And so that would be starting at 4 and going to infinity, which is everything on the right side of that. So it's going to go on forever. And this is going to just be an open circle there, but we have that solid circle in the green interval. So that's this one, and then the green one is this piece here. Okay, so let's look at the next one. So let's do this one in blue, from -3 to -1. So we're going to start at -3 and we're going to go to -1 and stop. Both of those are going to be open circles since we have parentheses on both ends. Let's do this next one in green. And this is going from -1 to 1. So starting where x is -1, follow it all the way to where x is 1. So it'll stop right there. And then this will have an solid point, and this will be an open point. Okay, so when you're looking at these intervals, you're just looking at the domain. Just look at the x values. Okay, we talked about all of this at the very beginning of the year, but let's do some review, or let's do some remembering. Recall that an interval is a set of real numbers that contains all real numbers bounded between any two numbers in a set. If an interval is considered unbounded on one or both ends, then it will include positive and or negative infinity. Intervals are always written from least to greatest. And we use brackets to include a number and parentheses to not include a number. The term bounded means that you will write an actual number, but unbounded means you will use a positive or negative infinity. So let's look at the different types of intervals that you could have. In this first one, it is on the left side, it's unbounded. But on the right side, we consider that bounded because it stops. So on the left side, it's unbounded. On the right side, it stops. And so for this, you're going to have a parenthesis on the left. And honestly, that's going to be your negative infinity. And negative infinity will always have a parenthesis. And then you'll just stop at A. So it's from negative infinity up to A. But notice that that A has a bracket since there is a solid point there. This next example is one where on the left side it's bounded and on the right side it's bounded. Okay, so they're stopping it at both ends. Notice that we have brackets on both ends and you want to write them from least to greatest. So you'll have A first and then B. And so what that means is it's the interval from A to B. On this next one, we have two shaded areas. So anytime you have multiple shaded areas, you're going to have to write as many intervals as there are areas. So in this particular one, we have two, so we're going to have two intervals. Now on the left shaded part, so over here on this side, okay, we can see that the left side is unbounded, the right side is bounded. So we're going to go from negative infinity up to A. Notice that we start with a parenthesis and we end with a bracket. The right shaded part is going to be this side here, and that on the left side is bounded and the right side is unbounded. So the left side starts at B, and that would be a bracket, and then it goes all the way to infinity, and infinity is going to be a parenthesis. So if you'll pay attention to the bounded and unbounded, it makes it easier to write your interval. Now when you have two intervals, two or more intervals, you're going to combine them with this union symbol. So we've talked about this before, but again, we're just kind of refreshing your memory. So your final answer would be from negative infinity to A, union B to infinity. Okay, remember about domain and range. Domain is the set of all x values from the left side to the right side. So you are going to have to write domain, and so remember you want to look at the left side to the right side. For range, it's the set of all y values from the bottom to the top. Okay, so in this particular example, the domain on the left side goes on forever, right? So if I bring that up to the x-axis, it's going on forever this way. The right side is also going on forever, so it's going on forever this way. And so it's everything between there, and notice that those two pieces are unbounded, and so your domain is going to be negative infinity to infinity. Okay, let's look at the range. So the range is at the bottom. Well, the bottom is going on forever. So on the y-axis, I'm going to show that this is going on forever. And notice that it stops right here where y is equal to 0. So the least value is 0. No, I'm sorry. Let me go back and erase that. The least value is actually negative infinity, and that's going to be a parenthesis. And then the highest value is 0, and that's going to be a bracket since it is bounded at that point. All right, let's review about positive and negative intervals. Positive intervals, it's the portion of the graph that is above the x-axis. So if I go over here and I look at the pieces that are above the x-axis, that's going to be this piece and this piece. So I would have to write both of those intervals. So this interval starts at -3 and it goes to -1. So -3, and both of those are bounded, so I'd have -3 to -1, both with brackets. Union, because we're going to have another section that starts at 2 and then it goes on forever. So we're going to have a 2 with a bracket and it goes on to infinity, parenthesis. All right, let's look at the negative section. The negative section is the portion that is below the x-axis. So if we look at our graph here, this section is below the x-axis and this section is below the x-axis. So now let's write those intervals. So the first interval is negative infinity up to -3. Negative infinity will be a parenthesis, -3 will be a bracket. And so union, we also have from -1 all the way to 2. And those are both brackets since we have solid points at those points. Okay, so positive interval is above the x-axis, negative interval is below. All right, positive and negative sometimes gets confused with increasing and decreasing. Increasing is the portion of the graph that goes uphill from left to right. So pretend like you're walking along this graph from the left side to the right side. So you would be increasing here, then you would be also increasing here. Okay, so we've got both of those intervals. So let's go ahead and write those. So the first one is from negative infinity to the x value of -2. Remember, you always write your intervals based on your x values. Union 1 to infinity. Now, something I should mention here is that a lot of the times when we're talking about increasing, decreasing intervals, we just automatically make everything a parenthesis. So, and it's kind of like a teacher preference. Some teachers have you put brackets there, but most teachers will have you just use parentheses. I should have said that on the previous screen as well for positive and negative intervals. I'll go over that again in class. Now, when we talk about decreasing, decreasing is the part of the graph that goes downhill from left to right. Okay, so if we're looking at this graph, right, the only part that's decreasing is this section right here. And so we would just have one interval, and it's from the x value of -2 all the way to +1. So increasing is going uphill, decreasing is going downhill. Okay, zeros, roots, x-intercepts, and solutions. These are all considered an x-intercept. So if we look at our x-intercepts here, we've got one there and we've got one there. this is going to be a point on the graph that touches or crosses the x-axis. So zeros, roots, x-intercepts, solutions. They are all your x-intercepts. Now, something that we talk about is called a double root. When you have a double root, it will bounce off the x-axis. This is considered a double root right here when it bounces off the x-axis, and it will not cross it. A single root will go through the axis. So this is an example of a single root where it goes through. What happens there is, you'll see it when we look at polynomials in factored form, is it's just going to have a single factor of like x minus 3. This one would have a double factor where you would have like x plus 2 quantity squared. So roots in this particular example are at -2, 0. We always want to write them as an ordered pair, and 3, 0. The double roots is just the -2, 0. Okay, triple root, we don't have any. A triple root it'll look like this. We call this a wiggle, because it doesn't really go, it goes through the axis, but when it goes through it, it kind of wiggles its way through it. A single root is just going to go straight through, kind of like a line. And then a double root will bounce off. And it kind of makes sense because this one kind of looks like a line. It's a linear term, which means it just has an exponent of 1. This kind of looks like a quadratic, which it is a quadratic, and so it has a double, an exponent of 2. And this looks a lot like a cubic root, which has an exponent of 3. Okay, now this is a term that's new to you. It's called end behavior. End behavior describes what happens to the y value at the extreme ends of the axis. So end behavior, again, describes what happens to the y value at the extreme ends of the x-axis. You always want to think of this as your left side and your right side. Those are your extreme ends. Now, notice what we have written here, because this is going to be the same every time. So how we read this is it says, as x approaches -infinity, f of x approaches what? Well, when it's on the left side, it's going up, and so we're going to say that y value, f of x, it approaches positive infinity. Now, on the right side, as x approaches positive infinity, so as we go this way, what happens to your y? Well, my y is going down, so we say f of x is approaching negative infinity. So really what you have to do is you have to be able to fill in this missing piece here, okay? And so you'll just have to recognize the left side is going to have x approaches negative infinity. The right side is going to have x approaching positive infinity, and that kind of makes sense. The x having negative infinity is over on this side, so that's the left. As x approaches positive infinity, that's this side, which would be your right side. All right, so here's something else that's new, even or odd degree. And so this will make more sense when we're looking at some equations. We call different things a degree. But if the end behavior is the same, then your degree is even. So if the end behavior is the same, the degree is even. So that means it's either both going up or both going down on the ends. So this would be considered an even degree because both ends are going down, and so this would be an even degree function. If the end behavior is going opposite directions, so you have one going down, one going up, then the degree would be considered odd. So I always think of odd, opposite, they go together. And so this would be an example of an odd degree polynomial because the right side goes down while the left side goes up. So opposite directions is going to be an odd degree. Okay, a couple of other definitions that you need to know. Turning point sounds like just like what it means. It's how many times it turns. So where does the graph change from increasing to decreasing or from decreasing to increasing? So this would be a turn and this would be a turn. So that would have two turning points. Okay? Then we talk about relative max and min. So we've talked about max and min before. A turning point on the graph can have a lowest or a highest point over a defined interval. You're going to write it as an ordered pair. So over the interval -3 to -1, there is a relative maximum right here. So it's going to have a maximum, and then you would write that ordered pair. So that ordered pair is -2, +2. So this kind of gets confusing because that looks like an ordered pair, but that's an interval. And I'll say that. It'll say interval blank. But this is an ordered pair, and they look very similar, and so you have to really pay attention. This unit is not going to be very hard. It doesn't have a whole lot of math to it. However, it does have a lot of definitions. Now, an absolute maximum, an absolute max or min, is it's the absolute maximum or minimum over the entire domain. So this graph has an absolute maximum right here. So this is an absolute maximum. This would not be considered an absolute maximum because it's not the highest point on the whole graph. This would be considered a relative maximum. Okay? So the absolute max would be the point, whatever that point is. Okay? This has an absolute max, which I can't tell what that point is because the graph is not labeled very, very well. Okay, that's everything for this section. You are going to have some practice problems that you're going to work on that are on your notes page there. So make sure that you have these definitions written down. Make sure you understand what they mean. Like I said, this unit doesn't have a whole lot of math, but it has a lot of definitions.